The air in the control room of reactor number 4 was thick and stale, illuminated only by the cold, insistent glow of cathode ray tubes. It was the dead hour, 1:23 a.m., April 26, 1986. Outside, the Pripyat night was silent, oblivious to the monstrous energy humming beneath the concrete floor. This was meant to be a simple test, a routine exercise in controlled failure. They were testing the turbine as ability to generate residual power during a shutdown before the auxiliary diesel generators kicked in, a safety measure designed to protect the reactor. But tonight, safety was merely a suggestion, a formality to be impatiently bypassed. There is a unique arrogance that breeds in the heart of industrial machinery, a belief that physics can be negotiated. The men in that room, steeped in the Soviet dogma of unstoppable power, were about to demonstrate this fatal hubris. They had deliberately crippled the system. Key automatic shutdowns were disabled, emergency cooling systems bypassed, all in the name of completing the test, regardless of the fluctuating numbers screaming warnings at them. The problem began hours earlier. To run the test, the reactor power needed to be drastically reduced, but the operators had reduced it too far. The colossal RBMK reactor began to poison itself. Xenon-135, a neutron absorber, accumulated rapidly in the core, suffocating the chain reaction. The power level plummeted to near zero, dipping into a territory the reactor design absolutely forbade. It was a perilous descent into darkness. Panic, masked by professional stubbornness, began to seep into the room. To claw the power back, they committed their first catastrophic error. They began to manually withdraw the control rods. Not just a few, but almost all of them. The rule book demanded that at least 30 control rods must remain inserted to stabilize the core. They pulled them until only 6 or 7 remained. The reactor was now running on a hair trigger, unstable, unpredictable, waiting for the slightest provocation. But the RBMK reactor held a terrifying secret, a design flaw built into its very architecture, a flaw the operators did not fully comprehend. This flaw was known as the positive void coefficient. Water usually acts as a brake on the reaction, absorbing neutrons. But in the RBMK, when water flashed to steam, it actually accelerated the fission process. It turned a cooling mechanism into an amplifier of destruction. Steam meant more power. More power meant more steam. An unstoppable, exponential cycle. At 1:23:04 a.m., the operator pressed the test button. The steam valves to the turbine were closed. The loss of steam flow caused the core's coolant temperature to rise. This was the moment the hidden design flaw began its work. The first pockets of steam formed in the upper sections of the core. A sudden, violent power surge registered on the dials. The reactor was accelerating, feeding on its own instability. The lights in the control room flickered, the air conditioning unit groaned, and a low, guttural rumble began to emanate from the depths of the reactor hull. It sounded like a massive, trapped creature trying to escape its bonds. The men realized their mistake too late. They saw the numbers climb at an impossible speed. The reactor was running away from them. In a desperate, final attempt to regain control, Akimov, the shift chief, ordered the emergency shutdown. AZ-5. The scram button. The ultimate safety measure. 1:23:40 a.m. The AZ-5 button was pressed. The control rods, tipped with graphite to displace the water as they plunged into the core, began their descent. This was the final devastating irony of the RBMK design. Because the tips were graphite, for the first few seconds of their travel, they did not dampen the reaction. They provided a boost, a final massive critical jolt of reactivity. The power level did not stabilize. It rocketed. The reactor went from a stable state to 100 times its normal power in the span of 4 seconds. The fission process went hypercritical. The fuel rods began to shatter under the thermal stress. A terrifying sound ripped through the facility, a sound described by survivors as the hammer of God. The immense pressure from the sudden exponential increase in steam shattered the thick pressure tubes containing the fuel. The water inside instantly vaporized, producing a shock wave of steam so violent it buckled the core. The first explosion. A massive surge of steam instantly lifted the 2,000-ton upper plate of the reactor vessel. It punched through the roof of the reactor building like a cannonball, ripping away the steel supports and raining concrete debris across the immediate complex. For a moment, there was a dreadful, echoing silence. The control room plunged into darkness. Dust and steam flooded the facility. Then, 2 or 3 seconds later, the exposed core, now stripped of its cooling and containment, violently mixed with oxygen from the atmosphere, the highly volatile zirconium cladding, and the burning graphite moderator ignited in a colossal chemical blast. The second explosion. This blast was far more powerful, a roaring, monstrous firework of destruction. It demolished the remaining structure of the reactor building. Flames shot hundreds of feet into the black sky. The 2,000-ton biological shield crashed back down, landing vertically inside the remains of the reactor shaft, crushing and burying everything beneath it. The entire 1,000-ton core of reactor number 4 was pulverized, ejected into the night air. Highly radioactive fragments of fuel, graphite, and pulverized metal soared above the rooftops, falling like burning invisible rain onto the surrounding area. Inside the control room, the operators were thrown against walls, deafened by the concussive force. When the dust settled, the air was suddenly hot, bitter, and metallic. They smelled ozone and something else, something sharp and terrifyingly unfamiliar. They smelled the ionization of the air. They were inhaling the pulverized heart of a nuclear reactor. Through the shattered windows, they could see what was left of Unit 4. It was no longer a building. It was a ruin. A gaping hole in the earth, topped by a terrifyingly bright column of white-blue light shooting toward the heavens. This was the light of ionizing radiation, the glow of the exposed core burning, reaching out to touch the world. Akimov looked at the dial that should have indicated the water level. It was empty. He looked at the pressure gauge. It showed 0. He whispered to his assistant Toptunov, "We still have water, Zhenya. It is still intact." They could not comprehend the scale of the destruction. The reactor was not intact. The reactor was gone. The core was scattered across the roof and the nearby power plant buildings. The silence following the explosions was the most terrifying sound of all. The sound of the world ending beneath their feet. The moment had passed, the moment of detonation. But the consequences, the silent, invisible rain of poison, had only just begun its eternal journey across the face of Europe. The light that shone above Chernobyl that night was not the light of controlled power, but the raw, uncontained fury of a star brought crashing down to Earth.